Hello viewers, my name is Dr. Ajay, Associate Professor, Department of ECE, Institute of Aeronautical Engineering College, Hyderabad. Today we are going to discuss about the problems on space wave propagation. So this topic is related to the course Antennas, Waves and Propagation. So today's topic is problems on space wave propagation, and this is related to the course Antennas, Waves and Propagation. So let us start our session. A transmitting antenna mounted at a height of 120 meters radiates 15 kilowatts of power equally in all directions at a frequency of 50 megahertz. Calculate the maximum LOS range, and the second one is field strength at a receiving antenna mounted at a height of 16 meters at a distance of 12 kilometers. So here in space wave propagation, here we establish an LOS communication. That is, a direct path is established between the transmitting antenna and the receiving antenna. We call it as a line of sight propagation. Suppose there is a transmitting antenna and this is the surface of the earth, and this is the distance of propagation. Here there is a direct path here. So here there is a direct path. When there is a direct path without any obstacles between the transmitting antenna and the receiving antenna, then we call it as the LOS propagation or line of sight propagation. So in the space wave propagation, we can transmit the frequencies on the range of 3 to 30 megahertz of frequencies. So in the space wave propagation, we can transmit the frequencies about in the frequency of 30 to 300 megahertz. So here, as shown in the problem, it is given that the transmitting antenna is mounted at a height of 120 meters. So here the height of the transmitting antenna, let us assume this as height HT. So HT refers to as the height of the transmitting antenna, and let us assume the HR, H suffix R, as height of the receiving antenna. As the height of the receiving antenna. So as shown in the problem, it is given as HT, the height of the transmitting antenna, it is 120 meters. And also the height of the receiving antenna, it is given as 16 meters here. The height of the transmitting antenna is 120 meters and the height of the receiving antenna, it is 16 meters. The transmitting antenna, it is radiating a power of 15 kilowatts of power. So what is the transmitted power? PT, let us assume this as PT. The transmitter power radiated. The transmitted power radiated, it is given by 15 kilowatts. So, and the frequency, the input signal frequency of the transmitting antenna, it is given as 50 megahertz. It is given as 50 megahertz. So this is the data given. So accordingly, we need to find out the value of LOS, that is the line of sight propagation. So this line of sight propagation depends upon the radius of curvature of the earth. So upon the radius of the curvature of the earth. So as seen in the theory classes, there is a formula to determine the LOS, that is D LOS, that is line of sight propagation. So the line of sight propagation, it is denoted by the symbol D LOS. We can also represent as D max, the maximum distance between the transmitting antenna and the receiving antenna. So this is given by 4.12 into root HT plus root HR. Height of the transmitting antenna plus root of height of the receiving antenna. So this is equal to 4.12 into root of HT. HT, this value is given as 120 plus root of HR. HR, it is given as 16 meters. Now let us simplify these two values. You will get 61.61 in kilometers. So this is in kilometers. So here the line of sight propagation, that is To establish a direct path between the transmitting antenna and receiving antenna, the heights are given here. It is 120, and this is at a distance of 16 kilometers. This is 120 meters. This is 120 meters. And to establish a line of sight propagation, what must be the distance here? So D is we got the D value as 61.61 kilometers. 61.61 kilometers here. So like this, we need to find out the value of LOS range. So we can also call this as a range. We can also call this as LOS range. We can also call it as a Dmax, the maximum distance of propagation. To establish line of sight between the transmitting antenna and receiving antenna, we can refer to it as a range or LOS range or Dmax. And here the second one, it is given as what is the amount of field strength the receiving antenna at a height of 16 meters at a distance of 12 kilometers. So here we need to find out the field strength of the receiving antenna. So the field strength of the receiving antenna, it is given by the formula ER is equal to 88 root P HT HR by lambda D square. So here this is the power received here. So what is the amount of power received? The amount of power, let us assume this as symbol PR. What is PR given in the data? It is 15 kilowatts. What is HT given? HT is equal to 120 meters. The HR value is, it is given as 16 meters. And F, it is given as, the value of F is given as, we need to find out 50 megahertz. So this is the data given. And here the distance of propagation, we just now have calculated, the line of distance is, it is given as 12 kilometers. It is given as 12 kilometers. So the D value is given as 12,000 meters. So this is the data given in the problem. So according to this data, we need to find out the value. So here we do not know the value of lambda. We need to find out the value of lambda here. So lambda is equal to C by F. Lambda is equal to C by F here. What is C here? 3 into 10 power 8 divided by, what is frequency here? 50 into 10 power 6 here. So 50 into 10 power 6. So if you simplify this, you will get 3 into 10 power 8 means 10 power 6 is 10 square. So this is 300 by 50. So you will get 6. So the lambda value is 6. Now we shall find out the value of field strength at the receiving antenna. Modulus of ER is equal to 88. Root P is nothing but it is root 15,000 into HD value is 120 and HR value it is 16 by lambda value is 6 and D is 12,000. D is 12,000 whole square here. So if you simplify this value of ER, you will get 23.95 millivolts. So the amount of field strength reached at the receiving antenna is given as we got as a 23.95 millivolts. So here in the problem all the data is given. So just we need to find out the value of lambda here by applying the formula lambda is equal to C by F. So we need to remember these two equations. One is the Dmax value, that is 4.12 into root HT plus root HR, and Dmax equal to, you can see here 4.12 into root 120 plus root 16, we will get 61.61 kilometers. Similarly, field strength at the receiving end is given by 88 root P HT HR by lambda D square. This is equal to 88 root 15,000 into 120 into 16 by 6 into 12,000 whole square. That is equal to 23.95 millivolts here. So calculate the attenuation at a frequency of 600 MHz when the distance between the transmitting and receiving antenna is 40 kilometers and the gains are 20 dB here. So we need to calculate the attenuation. So here the attenuation, it is denoted by the symbol LS. So here the frequency is given as 600 megahertz here. And the distance between the transmitting and the receiving antennas is given as it is 40 kilometers. And the gains are assumed to be the 20 dB. That is the value of transmitting gain antenna and the gain of the receiving antenna, both are assumed to be the same here. So let us assume GT as the gain of the transmitting antenna. Let us assume GR as the gain of the receiving antenna. Let us assume this as 20 dB here. GT is equal to GR is equal to 20 dB. So here we are having a formula as a spatial path loss, which is expressed in dB. This is equal to 32.45 plus 20 log D in kilometers plus 20 log F in kilometers. So if we simplify this by applying the formula, you will get the value of LS 32.45 plus 20 log, what is the value of D? It is 40 base 10 here, plus 20 log, the value of F is given as 600 base 10. So if you simplify this, you will get the value as 120.056 dB. So if we simplify this, we will get the path loss. The path loss is equal to 120.056 dB. Now we are having a formula based upon the ratios of the power received to the power transmitting antenna. So here PR by PT is equal to GT plus GR minus LS. Minus LS here. So here PR by PT is equal to 20 plus 20 minus LS is 120.056. So you will get a minus 80.056 dB. Here this minus indicates that the minus in the value indicates that there is the signal is being attenuated by a value of 80 dB. So here the attenuation at a frequency, calculate the attenuation at a frequency of 600 megahertz when the distance between the transmitting and the receiving antennas is 40 kilometers and the gains are 20 dB. So here in the given problem, the data is given as the gains of the transmitting antenna and the gain of the receiving antenna. It is given as GT is equal to GR is equal to 20 dB and the frequency is given as 600 megahertz. So based upon the formula, we can find out the value of LS. That is LS equal to 32.45 plus 20 log D base kilometers plus 20 log F base 10 megahertz. So we are given the data as a D is equal to 40 kilometers here and F is given as a 600. Just substitute here. This is there's mistake here, 600. This is in megahertz and this is kilometers. If you simplify this, you will get 120.056 dB here. So here the ratios of the power received to the power transmitting is there is a relationship between the gains of the transmitting receiving antenna to the ratios of the power received to the power transmitting antenna, which is given by PR by PT is equal to GT plus GR minus LS. This is equal to 20 plus 20 minus 120.056. So how much the signal is being attenuated? It is by minus 80.056 dB here. So this is the value of attenuation. So let us have a recap of what we have seen now. So we have seen the LOS propagation, the line of sight propagation, which is denoted as DLOS. It is given by 4.12 into root HT plus root HR. And similarly, we can find out the value of the field strength reached at the receiving antenna. It is 88 root P HT HR by lambda d square. And the path loss. The path loss also we can also find out by the formula LS in dB is equal to 32.45 plus 20 log D plus 20 log F in megahertz. This is in kilometers. This is based on and this is based on. Also, we have seen the ratios of power received to the power transmitted as GT plus GR minus LS in dB. So this is in dB here. This is in dB here. So these are the formulas which we are used in the space wave propagation. One is the range, one is the field strength, and also what is the amount of path loss occurred when we transmit a signal into free space. So here you can refer these textbooks. Here the antennas and waves propagation by U.A. Bakshi. You can also refer the textbook K.D. Prasad, that is Antennas, Waves and Propagation by K.D. Prasad, 2001 edition here. So whatever the problems that we have discussed now, for those problems you can also refer these textbooks. And for more problems you can also refer the textbooks Balanis, Antennas and Waves Propagation by Balanis. And also for more problems you can also refer John D. Cross textbooks. So these are the standard textbooks which you can follow for better understanding or for better doing of problems. So let us close the session today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.